the role of protecting group just to avoid the chemoselectivity issues which is occurred during the retrosynthesis process. So here is an example. If you have a two functional groups and you are interested is to reduce less reactive functional groups over the more reactive functional groups. In such cases, people will try to use the protecting group and protect the more reactive functional groups, and they will do the reactions on the less reactive sites with the available reaction condition. So in this case, the more reactive site is C double bond group. So you need to protect it because the next step is the reduction of COOET into corresponding alcohol. Suppose if you are using a reducing agent without using the protecting group, then obviously the reaction site is C double bond group as it is more reactive over the ester. So here they have used 1,2-diol, that is ethylene glycol. And certain qualities needs to be present with respect to this protecting group. These three qualities: one is it must be easy to put in, and it must be resistant to reagents that would attack the unprotected functional group. So the reagent what you're using as a protecting group should not interfere with the rest of the functional group. So it needs to be too specific to the particular site, and it must be easily removed after the end of the reaction. So the example is aniline. Suppose in absence of like any amide functional groups, if you have only NH2, it is an alternating group, and if you try to do the electrophilic substitution with the help of bromine acetic acid, you will get a 2,4,6-tribromoaniline. And suppose if your aim is to have only one monobromo aniline, then you need to use the protecting group. So how to use the protecting group? You need to take the aniline, then you need to introduce the protecting group, that is acetic anhydride you need to use as a reagent, and NH2 will be converted into corresponding amide. Then you need to introduce the bromine acetic acid in this step, second step. Then only the bromination occurs at the fourth position. So resultant will be 4-bromoacetaldehyde, then followed by deprotection step, that is you need to use HCl, dilute HCl in ethanol, then hydrolysis will take place, particularly at the NHAC site. Then you will get the 4-bromoaniline. This is the desired product. Similarly, you can use this Achilles heel strategy also. You need to take this as a reagent, and what will happen if you have a certain functional groups, reducible functional groups, which is present over this R functional group, along with the OH functional group. Then your reaction site is not the OH, so some other sites which is present in the R. Then you need to protect this OH first. So how to protect? You need to use this DHP, dihydropyron, as a reagent. So what will happen? It forms an acetal, that is weak acetal bond formation. So usually acetal formation. So this is the acetal. After that, you can do the reduction on any functional groups, reducible functional group which is present on the R. So after the reduction step, you will get the R dash. This should be an R dash, and this is actually helps for the protecting of this particular functional groups, OH. Then what will happen? So at the end, you need to deprotect this protected OH in order to get the free OH. So because you have performed your intended reaction on this particular R, and converted it to R dash. Now R dash OH, you will get it after the hydrolysis. So most of the times, like for the deprotection, weak acid is sufficient to cleave the bond cleavage. Like in this case, this acetal cleavage is the weak bond, and it is the most preferred one. And in case of paracetamol, suppose if you want to prepare, then what there are two functional groups, NH2 and OH. So you can do the acylation with the help of acetic anhydride or acetyl chloride. No, you can treat with the acetic anhydride or acetyl chloride. Then there are two possibilities. NH2 and OH, both the functional groups can undergo reaction. But you know the reactivity, NH2 is more reactive over the OH. In such cases, this is the preferred reaction. So suppose if you are not intended to perform the certain reactions over the NH2, then you need to concentrate on OH. In such cases, you need to deprotect it, NH2, into the some other form. So here is the cleavage corresponds to the paracetamol. First CN amide cleavage, then NH2OH, FGI, NO2, then CN nitration. You end up with the starting material of phenol. And using the phenol, you can reconstruct this. So the synthetic step is available to get the paracetamol is you need to start with the phenol, then dilute HNO3, that is the nitrating mixture, you need to use it. Then you will get the 4-nitrophenol. Then followed by second step is H2PDC, that is hydrogenation. So NO2 will be reduced to the NH2, then followed by acetic anhydride. So if you use acetic anhydride, of course NH2 is the highly reactive over the OH, then you will get the paracetamol. Then coming to this, here, what will happen when you're using NaSH and Na2S? So the reaction site is alkyl halide. So you're converting alkyl halides to corresponding thiol. This was the intended reaction or SH. But what will happen during the synthesis of this kind of reaction, because Na2S, so usually S2 minus. So that is nucleophile, it will access a nucleophile and attacks over the carbon, that is R, carrying the leaving group. And it attacks over here and leaving group, that is Br minus, leaves out. And desired product is RSH. But as soon as this RSH is formed, along with that there is a HS plus. And what will happen to this RSH is RSH once again acts as a nucleophilic, electrophilic center here. Nucleophilic center, because H plus you need to remove it and S minus. This RS minus will compete along with the existed HS minus. Then this RBr is still present, and S minus formed RS minus is more reactive over the available HS minus. So in such cases, this S minus prefers to attack over the RBr, and resultant will be this sulfide 4 formation. So here your aim is to get only RSH as the product, but during the reaction you won't get RSH, you will get this sulfide because of more reactivity of the product formed in the first step. If it is only reactant or more reactive, then product formed is less reactive, then you can expect this RSH is the end product. But in this case, during the reaction, after reacting with these two reagents, you will get the RSH. The formed RSH product is more reactive compared to the one of the reactant, that is HS minus. This will act as a nucleophile and tries to attack over the available or excess reagent of RBr. Resultant will be formation of sulfide. The problem from the 1 and 2 may be solved by protecting group. If you want to reach the less reactive of two functional group, we protect that the more reactive. Suppose in the case you have a two functional groups, like this was if you have a two functional groups, which is one is more reactive and another one is less reactive, and which is more reactive, but you are not interested to perform the reduction reaction over the C double bond group. In such cases, first more reactive site you need to be protected and try to perform the less reactive site. You need to perform the reaction. Resultant will be, you will get the expected product of this CH2OH. Suppose without the usage of any protecting group, if you try to perform, then more reactive site will react, the less reactive site will be inert. So you cannot expect this kind of product. If you want a reagent to react once, when it could react twice, we protect reagent. So in this previous case, we want to react this HS minus with the RBr only one time in order to get this RSH. But what will happen? So after the formation of RSH, it will start reacting with one more time with the RBr. So in such cases, you will get the unwanted product of disulfide. But our intention is to get the two. In such cases also, you try to think about the usage of protected group. So if you introduce the protecting group, then you can stop the particular level instead of expecting the unwanted product. So if we want a reagent to react only once when it could react twice, we protect the reagent. A protection group is something add to a functional group that reduces or eliminates the unwanted reactivity. So what is the role of protecting group is it will protect this functional groups, and that protected functional groups will not interfere during your functional group conversion step. So only thing is it will protect the functional groups. Like in the previous example, C double bond O is the reactive site and it has been protected. Only ester is available for the reaction. Here is an example, one more amino acid chemistry also. You have two functional groups, NH2 and COH, right? Amine is more nucleophilic than the carboxylic acid. So if you want to use carboxylic group as nucleophile, not the amine as a nucleophile, then you need to use the protecting group and protect the NH2 first. Then COH is only the available site for the reaction. Then you can perform the reactions over the available COH. So how to protect NH2 in amino acid chemistry means you need to protect the amine group by benzyl chloroformate. So benzyl chloroformate can act as a protecting agent. It protects specifically the NH2 which is present in the amino acid. So it won't interfere with the COH. So it cleanly isolate the amine group to give the carbamate 3. If compare 1 and 2, the carbonyl group becoming less electrophilic. So this is the amino acid, and forget about the R. So R can be of any alkyl group. Then in amino acid, this is the common, right? NH2 and COH. So suppose in absence of protecting group, if you want to perform any reactions, then NH2 will act as a more nucleophilic center and it will interfere with the reduction reaction or any other organic reactions. So in such cases, you need to protect the more reactive, that is NH2, with the help of any protecting agent. So the available protecting agent which can protect this NH2 is you can use the benzyl chloroformate. This is benzyl chloroformate, which protects the NH2 and forms this particular protected functional group. So now there is no free NH2 for the reaction after the protection. Now only available site is COH. So now it is easy for you to perform the reaction because there is no interference from the free NH2, because free NH2 you have converted and you have protected the NH2 with the help of this protecting agent. And this is actually less electrophilic too because of resonance stabilized. This will be in resonance. Even any nucleophile, if it is approaching, it won't interfere with this particular carbon because this is in delocalization. So this is less electrophilic center now, this particular carbon. Then compared to this COH, this is less electrophilic carbon. And this COH is carbon of this COH, carbonyl carbon of COH is more electrophilic. That's why the nucleophile prefers to attack over this carbon of COH, not the C double bond O of amide or the protected group. So thereby you can perform the reactions over this site easily and you can get the desired product. After that, try to cleave this or do the hydrolysis. You will revert back this NH2, free NH2 and the modified COH.